I'm Mike Stahnke. I'm the VP of Platform at Circle CI. Platform is one of those words that is ambiguously accurate. It can mean whatever you want it to mean. And for me, what it means is I run site reliability engineering, release engineering, security engineering, execution environment, machine jobs, and backplane teams for engineers at Circle CI. Basically, most of the people that aren't doing the core UI work at Circle CI are the engineers that work for me. We'll talk a lot about what Circle's doing, why they're doing the things they do, and how it integrates with what's going on at Puppet, along with the State of DevOps Report. So I was at Puppet for 8 years. I'm a big fan of the community. I've done a lot with Puppet, tried to grow a lot of things with Puppet, still love everybody at Puppet and everything going on here. I got a new opportunity. I took it. That's great. I'm really happy about it. But I was also excited that I still got to participate in the State of DevOps Report this year in 2019. My company, Circle CI, was a sponsor. I was still able to be an author. And so I was also an author in 2018. I'd worked a little bit behind the scenes in some of the years prior to that on some of this stuff. So basically, over the last decade, I've been eat, sleep, breathe DevOps. So that's what I want to talk about, is DevOps and performance, and does this stuff actually work? So I'm going to talk about a lot of different data points, and we're going to categorize them in different ways. And that's going to continue on as a theme throughout the rest of the presentation. So we'll start with things I didn't need to know, but I'm now happy I do. And they'll get tagged with, oh, cool. All right. And then we have things that don't seem obvious at first, but then they kind of are once they're explained or thought about for a little bit. And that gets, oh, comma, yeah. And the O is for the pause. It's not, oh, yeah, like Kool-Aid Man. It's, oh, yeah. And then we have things that make you feel better about your team and their performance. Now, do they actually make you feel better? I'm not sure. They might make you feel better. You might cry a little bit because your team is so different than what we're going to talk about, but that's okay too. But those get, oh, wow. Okay. And then we have things that conventional wisdom says are great, and there's no data to actually support that these are true. And that is, oh, snap. So those are the 4 types of data points that we'll talk about today. Now, as a disclaimer on this, I am not a data scientist. I am really, really not a data scientist. I wasn't even that good at statistics in college. What I am good at is running SQL queries and asking other people to do my work for me. That's why I'm a vice president. So I did get a bunch of help from people and various sources to get some of this data. I did not do all of it myself, and I will thank the appropriate parties as I get to those data sets because they're interesting. So when I got to Circle CI and I was thinking about all these DevOps surveys that we've done over the years, the thing that fascinated me was there's this giant data set of what humans actually do when they build software. And it's not a survey, so you're not filling out a question. It might depend on your mood. Like if you take a DevOps survey 3 weeks apart, I imagine the answers would be slightly different. Because one day it could be, this application or service is great. Then 3 weeks later it could be, wow, we've just had 4 outages. We're terrible at everything. I hate my life. Those things all happen. And so surveys are a little bit more reaching into the human aspect of this. I wanted to remove that because sometimes computers can tell you things that humans can't. So this data set is 1.6 million jobs per day. 1.6 doesn't look very big when you write it down, but when you think about 1.6 million, okay, so that's 100,000, 16 times 100,000 is a pretty big number. So there's a lot going on every day here in this data set. So more than 40,000 orgs. More than 40,000 companies providing data into this data set, doing work on Circle CI. So there's a lot to learn from. Now, an org could have 5,000 developers, it could have 1 developer. So there, and we'll talk about some of those variances at different times. More than 150,000 projects in this data set. So that's a lot. Again, I just wanted volume. What we lack in real data we'll make up for in volume. And you can also find really statistically significant things in a data set when it's this large that, even if you're moving the needle 2 or 3%, that can be statistically significant in certain cases. But in the end, what we're really looking at is a collection of more than 30 million jobs. This was about 90 days worth of data for us that was selected for reasons that it was basically easiest to slice and dice. Like, to be honest, that was why we picked that size and that set. But 30 million workflows. And so when I think about 30 million workflows versus surveys, we've done a lot of surveys with the the Puppet DevOps Survey is the largest collection of DevOps research that has ever been assembled, right? Cool. The Circle CI data set is not DevOps research. It's just a giant data set that I'm going to go try and pull out some DevOps stuff out of and find out things. But this is more than 1,000 times larger than all of the data we've ever collected from a DevOps survey. So just to give you some enormity of it, there's a lot of data going on. There's a lot of stuff flowing through Circle CI on a regular basis. So let's get to the hard-hitting facts that matter. The most common length of a GitHub repository name is 17.6 characters. The best part of this was I asked a friend of mine who works for me, I said, what do you think, how many characters do you think the average repository is? And he goes, 17. And like without it, he didn't hesitate at all. And then we ran all the queries and everything, and it was 17.6. And so I was like, all right, you win this one. The most common project name is API, because developers are super creative and really good at naming things. Followed by Terraform, which I found very interesting, because I feel like there's only one Terraform, but apparently lots of people have their own repos called Terraform, which I think is crazy, but okay. And then infrastructure and web. And so if you want to make the John of GitHub repos, you name your project API, Terraform, infrastructure, web. And then you can be just like everybody else. So if you take away environmental names for branches, like dev, test, stage, prod, the most common branch name is update readme. Which, you think about that at first and you're like, wow, do developers actually update readmes that often? And they do, but there might not be a good update, let's be real. Like you fixed a spelling error, you added a copyright, you added a contributor, you didn't actually help the user of the project most of the time. Readmes are not that helpful a lot of times. We can all do better. But the other thing is update readme is a default branch name if you're editing in the UI on GitHub. And I didn't realize that at first. So then I was like, okay, well now I got to control for that because GitHub has named the branch for us rather than us doing something else. So if you take out GitHub generated branch names and environmental names, the most common branch name is fixes. Because developers are super good at naming things. All right, we had 31 million data points. And this is the kind of stuff I can talk about. Isn't that awesome? Hard-hitting DevOps stats. So 0.01% of workflows have swear words in the branch names. English swear words. I should say that I did not control for other native tongues because while you think that you learn the swear words from other languages first, you kind of do, but I don't know that many languages. Anyway, it was English. That was what I was looking at. But the thing is, this probably isn't you. What I found really interesting was out of the 150,000 orgs, only 359 of them had ever done this, which leads me to believe that there are some profane orgs out there. Also, the branch names are hilarious with swear words in them, but I'm not going to put them up on this stage. And this doesn't count commits because I'm sure commits are way, way worse. So really what it was, I had this data set of 31 million data points. I have years of research from the State of DevOps Reports. How do I combine these to say, okay, you have reported behavior and you have actual behavior. And how do we look at this? And what is that really? That's actually what behavioral economics is. And I'm really into behavioral economics. If I was going to go back to school, I'd probably study economics. So this is Dr. Richard Thaler, Dr. Stephen Levitt. They're at the University of Chicago, kind of the founders of, I guess I would say, behavioral economics. Some people would call that freakonomics. But if you look at how this is happening in the DevOps world, that was really what I wanted to talk about. That was how I was pitching this talk and how I wanted to think about it when I had access to this giant data set was survey says you do this, data says you do that. So I combine all the knowledge that Puppet has over the years, which is super awesome, and a giant data set from Circle CI, and we'll see what happens. So traditionally, the things that really are kind of the DevOps works, and we can show you, because here's the correlations that lead to better business outcomes. This has kind of been the classic slide that has been shown many times for these types of reports and marketing materials and the why you should do DevOps and, how do I know that I should be doing DevOps? How do I convince my manager to do DevOps? Whatever it is that you're having this conversation about. But it's 200x, 24x, 3x, way shorter lead times, like all these things, and they're great. And then in 2018, we shifted from DevOps is better to here's how you do DevOps, more with a prescriptive path. And so that was a really cool shift for the 2018 report. But I'm going to actually go back to these stats that are a little more kind of correlated to show what's going on, because that's the part I can dig apart from a statistical analysis point of view. So again, State of DevOps Reports, throwing Circle CI on top of it, right? In 2019, we actually talked about security a bunch as well. And by the way, we have beautiful hard copies of these if you really want one. But we talked more about security and how integrating security into DevOps really leads to better outcomes, both from a business standpoint, from a security standpoint, and really if you're great at security, you're probably good at DevOps. If you're really good at DevOps, you're probably pretty good at security. There's a lot of correlation there. It's really interesting to think about and break apart. There's also a ton of cynicism in there. Chances are if there's a sidebar that sounds like a rant, I wrote it. So that's the 2019 report. But what I wanted to do was figure out how I can map the set of Circle CI data onto the things we've been talking about classically for years from Puppet's data set. And so I started to think about this. Deployment frequency. How often do you kick off a workflow? If a workflow contains a deployment, a workflow is, let's see, in most tools, I think it might be called like a pipeline. It's a collection of jobs that do things, is basically what you need to think about from a workflow. How often do you kick off a workflow? That's an indication of work happening in some way. MTTR. Time from a workflow being red to a time to a workflow being green. Or a workflow being blue if you're a classic Jenkins user. So, blue. Change failure rate is a workflow failure rate. So you made a change. How often do those workflows fall over, fail, just turn up red? There's a rate that's different than recovery time. And then the lead time. How long do those workflows take to run? How long until you get the feedback or you get the deployment out in production or whatever it is that you're trying to do with that workflow? So those roughly map to those 4 things that I was showing on the slide earlier. And that's how I was really trying to look at the Circle CI data set. So in economics, there is a prototypical person they use to explain expected behavior. And his name is Homo economicus. And they do this to say that this is a completely rational human, and they will always make the right decision based on the data provided. And it's the stupidest things in the world when you actually understand it, because it's things like, I bought this, but I would sell it to you at a greater price. So it doesn't ever factor in things like sentimental value or scarcity or like different things like that. There's a lot of things that don't get factored in. But it's very interesting to ever read case studies about Homo economicus, because assuming humans are rational, first off, is just a terrible, terrible assumption. So I decided that I was going to make my own persona of how we do representations. And so this is Homo DevOpticus, and I was not nearly the good artist that the previous thing recommended, and so I just went with Shrug because I felt like that is used an awful lot in my industry. So that is the avatar for Homo DevOpticus. So if deployment frequency is how often you kick off a workflow, let's dive into that a little bit. How often do you kick off a workflow? Well, wow, I totally messed up that slide. All right, workflow duration, minimum 2.1 seconds, right? So the fastest workflows that are completing on Circle CI are happening in 2.1 seconds. And you think about that for a second, you're like, well, what is that workflow doing? I can exit 0 super quickly, right? Maybe it prints a message and exits 0. Like that could be what it is. I have no idea. But the maximum workflows take 3.3 days. What's going on in 3.3 days? I would bet a whole bunch of tests, test suites, regression suites, integration suites, spinning up external dependencies on databases, on LDAP directories, on running performance tests, doing builds after builds, maybe cross-compiling for multiple platforms. Basically, real software, really complicated stuff going on, 3.3 days. Okay, that kind of makes sense. But the 50th percentile in a giant data set of workflows finishes in 3 minutes and 27 seconds. All right. The 95th percentile is 28 minutes. So 95% of those 31 million builds or workflows finishes in 28 minutes. 28 minutes is an interesting time because when I think about that amount of time to do work, there are certain teams that 28 minutes means that you would have mutiny, anarchy, and like the place being burned down because it takes too long to get feedback. There are other places where 28 minutes, you would have celebrations and parties and dance-offs because you were just so happy. about what was going on because you got all of your feedback in 28 minutes. So it really varies on what type of software you're building, how deeply integrated your tests are, how complicated your tests are, how well you're testing. Did you actually write tests? By the way, you should write tests. So, okay. So this is kind of the summary. You have minimum was 2.1 seconds, which I think was basically some type of exit 0, maybe print a message exit 0. Maximum 3.3 days, probably a very complicated test suite. But in the middle, between 3 and 28 minutes. Feels about right, okay. I'm going to do a sidebar on deployments for a second. 25% of workflows have deploy in the name. What does that tell me? Literally nothing. I do not know if they're actually deploying. Some people just write the words deploy. Some say build, test, deploy. Sometimes it's the build, test, deploy, deploy without the build. I'm thinking about deploying. Like some of the workflow names are amazing also. Workflow names also have swear words in them, but I didn't do that stat on it. How often people are deploying, though, is a little bit interesting. Way on the right-hand side over here, you can see that there are people that are basically kicking off workflows between 1,500 and 2,000 times a day. That's a lot of data to go parse through. Like, can they use that? Are they getting results before they kick off the next workflow? Probably not. That doesn't seem super healthy, but then there's other people that are much more in this lower case. This is a nice wave, it looks pretty. But so most people are committing workflows, building them at way lower rates. The ones that look like these straight lines, I believe are like default scheduled jobs. But if you look at this, okay, workflows per day, on average, people have 3. 95th percentile, 29. Max, 2,488 workflows a day. Again, I'm not sure how you get feedback and use that in any meaningful capacity. And that's basically one workflow. So it's not like it's an org doing all sorts of different projects and things like that. So it's a little weird. But the thing that's interesting to me is workflows on master per project. So you're getting 1 merge a day. 95th percentile is 13 merges a day. Where's that? We deploy 3,000 times a day. We deploy 300 times a day. All those stats that you hear about all the time. At a conference, at a talk like this. They're not real. Okay, there's not a lot of companies doing that. Obviously, there's some that have, a 39 or they're doing 2,400 or whatever. But most companies are not moving that fast. The other thing I will say about that is deployment frequency to me is a vanity metric. If you can deploy when you want to, after that, I don't care. So, MTTR, time from red to green. Fastest recovery from a red workflow to a green workflow is less than a second. How does that happen? Easy, you kick off 2 workflows, one of them was terrible, and one of them was good, and they finished at almost the same time. So that's really what happens, because there's no way you can actually recover something in less than a second. The absolute max for recovery time is 30 days. By the way, in that 30 days, you might not have actually recovered. That's just when the timeout happens. So it's red, meh. Okay, that makes sense. No one's ever had like a job just sit there red for days and never looked at it again, right? It's never happened. It's happened. But the median recovery time is 17.5 hours. That shocked me. I was expecting it to be in the 90-minute range, the 60-minute range, somewhere in there. 17.5 hours. What that basically tells me is developer pushes code, gets some feedback, looks at it, and says, it's red. Screw it, going home, I'll work on it tomorrow morning. That's about 17.5 hours. It's the end of the day, you go home, you sleep, you commute back in, and all that. That's when you get back to work. So, turns out red workflows are pretty demotivating. So, 17.5 hours. I categorize this one as snap because, again, I think that's against conventional wisdom for how long it takes people to recover things. Now, here's a little bit of summary on mean time to recovery. Less than a second, 30 days, 17.5 hours. The 17.5 hours is the only thing I find interesting out of those 3. But why is it 17.5 hours? Why is that so different than the data set that's generated in surveys? And part of this is because the way the survey questions are written, it asks them in a very specific way. It says, for the primary application or service you work on, tell me about foo. Circle CI doesn't know what the primary application or service you work on is. It looks at all your workflows, all your jobs, all your projects, and it says, here's the time. So it might be that your primary application, you actually are very good at recovering. It could be that you're doing that in an hour or in 20 minutes or whatever. This is looking at an aggregate of everything you're doing. Do you have some projects that a red build is just not that important? Probably. So that could be why it explains some of the differences. So let's look at workflow failure rate. Overall, 27% of all workflows on Circle CI fail, at least in this 31 million data point set. 27%. Okay, that feels about right. 1 out of 4 fails. That doesn't seem terrible. I'm also of the camp that a failing build is not a terrible thing. It means the CI system worked and gave you valid data. Some people think that it should always be green. There's different schools of thought on that. I'm okay with red builds as long as you fix them. So, but what do you think the rate is on master? Because that was on all branches, right? 27% on all branches. Do you think it's higher or lower on master? It is lower. Yeah, so it's 18% on master. So you basically drop 11 points, 9 points, math, 9 points by working on master, which is probably fine because topic branches should probably fail more often than master. If you're merging into master, you should have a better idea of what's going on. So on topic branches, you're at 31% failure rate to get that average of around 27, which tells you that there's a lot more topic branch workflows going on than there are master overall. Let's talk about failure rates for a minute, though. That really wasn't supposed to be there. Okay. I think I must have dragged and dropped a section and moved it. Anyway. We'll go through this. Manual approvals. One of the things that does happen is that there's a manual approval option inside of Circle. And honestly, this is one of the reasons that I think Circle CI is really cool, which I realize is really weird, coming from a guy who studied DevOps for 10 years and into continuous delivery. Manual approvals are the last thing that anybody thinks you should ever do, because humans should not be involved in getting software out to production, right? Well, I live in the real world where humans are involved in how software gets shipped. And so manual approvals are pretty cool. They seem antithetical, but let's talk about that a little bit. Some workflows can contain more than one approval. So you can have an approval maybe to go from a staging environment into production or from dev into staging or whatever. Approvals are a construct built into Circle CI. So 3.5% of workflows contain a manual approval. Okay, that's not a huge number. That seems reasonable, I guess. But remember, there's a 27% failure rate on all workflows. What do you think the failure rate is on a workflow that contains a manual approval? It's 3%. So what does that tell you? That when you have manual approvals involved, your work is way more likely to succeed. Now that's correlation, that's not causation. I'm not saying put manual approvals in everything and therefore you will do better work. It could be that because you know somebody's going to look at this manually, you do better work ahead of time because you're like, wow, my boss is going to click approve or disapprove on this thing going on. I should probably have a good story to tell them. It could be that the workflow is a very simple workflow that only contains one job and just has approve or disapprove, which means you can never fail. I don't know. But I did find it interesting that the approval rate was so much, or the failure rate was so much lower on workflows that contained approvals. A workflow duration, if you remember, the median was 3 minutes and 26 seconds for how long a workflow takes. Well, with an approval, it takes 14 minutes and 38 seconds instead of 3 minutes because you're waiting for an approval. Now, to wait for an approval for only like 10 minutes seems pretty okay. I was very pleased with that because I think it's just an email or a Slack notification to say, like, there's an approval waiting for you. And if you get a response from whoever's approving your workflow in 10 minutes more or less to get your job done, that's really not a high tax to pay in the grand scheme of things for how approvals happen. So again, that was kind of impressive to me. We also have a thing called scheduled jobs. And so you can schedule a job and just be like, run the tests at this time. People that do this are usually the ones that are committing so fast that if you do testing on commit, you're basically just churning the system and you're eating all your credits on Circle CI, and we're making a lot of money, which is great, but you're not getting a lot of results for it. So they just do, okay, once an hour, we'll just build with all chain sets. But the failure time on these, or the recovery time, is much, much longer. So from 17.5 hours, you go up to 24 hours. And it's basically when it's a scheduled job, there isn't that sense of ownership. Even if that sense of ownership was, I pushed the thing, it failed, I'm going home, I'll work on it tomorrow morning, you at least remember to work on it tomorrow morning. The scheduled job is, oh, I probably should have looked at that. That ran yesterday at noon. Now it's lunchtime. I guess I should look at it again. And that's really what happens when you're looking at recovery times. So 17.5 hours, scheduled job recovery time, 24 hours. One more sidebar on failure rates, because failure rates are fascinating to me. Languages. What the actual? So I think what I'm telling everybody is that you should be a PHP shop. Right. So I thought about this quite a bit. And my conclusion, which I have no data to support, is that PHP users don't write tests, which is why they succeed all the time. Something else that is interesting, though, is if you look at the number of users and the number of branches, in most cases, you just take the number of users squared, and that's how many branches you get that are active. Things like Ruby, I think, one, testing was built into the Ruby culture from very early on, like TDD and behavioral-driven development really was in the Ruby culture from as early on as I ever saw Ruby, which was in the early 2000s. And more users, a little more branching, a little more collaborative, I would say. And I thought that kind of panned out, and that one made sense to me way more than the PHP thing did. I'll say that. So we're back to State of DevOps Reports. You saw some of the numbers that went through, like at a very top-level survey overall, survey being the scan, not survey being you filled out the form, of the data set that CircleCI has. So where does that put us on this type of chart? Are we in the high performers, medium performers, low performers, if you're running on CircleCI or you're doing CI, you're doing continuous integration on a regular basis? Well, in most cases, you're put on the border between high and medium performer, just if you're in the 50th percentile of what's going on in CI. So what I'm telling you is that if you use CI and use it for real, and you're just average at it, you'll be right on the borderline between a medium and a high performance team. That's how I sell you CircleCI. But you can see that lead time for changes, you're in the high performing category automatically. But most of ours are right on the border in the average. Now, if you're in the 95th percentile, in most cases, you're up here in the high performers. So what that really is saying is that doing CI and doing it well is a key indicator of team performance. Which is great, because I want you to use CircleCI. But when CircleCI started to really think about, okay, we have these metrics, we have these DevOps survey metrics, we can correlate them with our data set. What is the thing that we are passionate about beyond just that? And it's delivery team productivity. How are we really measuring that team productivity? And so we want to put some different measures in place that are, I would say, associated with those metrics, but maybe a little bit different. You should just count lines of code. That's really what you should do. That's how you know if a team is productive or not. We're not going to do that. Do the defects rate go up? What's your contribution rate on GitHub? Those things are all things that people approximate for team productivity, in which, in all cases, they're pretty much bunk. So let's not do those. What we really cared about was master branch stability and deployment frequency. How stable is the thing you're doing, and how fast can you move it? I need confidence and velocity. Confidence and velocity. That's what I want for team productivity. Disclaimer, I'm not a data scientist. So, we have a formula for how we calculate this data. We came up with this thing called net value score. And this was come up with by a data scientist, because we employ data scientists. I am just not one of them. And so what we want to do is look at the count of red builds versus the count of green builds, as compared to the amount of time you spend red versus the amount of time you spend in a green state. And the reason we have the ones, minus, and plus is so that you can basically cap the score between -1 and 1. So if you're at -1, you're probably not doing too great. If you're at 1, you're pretty badass, and you're somewhere in the middle probably. This will make a little more sense when we start plotting it, but basically, you want to get penalized for more red, you do good for more green. That's more or less what it is. So what you'll see in these scatter plots are things like, if you have a higher NVS, you can move a lot faster. You don't see a lot of things pushing 200, 300 builds unless you're quite good at keeping your branches stable, and your amount of time you're spent with a red build sitting there is pretty low. This curve basically shows you that once you start getting pretty good, you can move a lot faster. Now, for some of that, okay, let's correlate that to branches per user. Like, how many branches are on these projects, and does that change your net value score? Well, if you have a lot of branches, sometimes you can move pretty quickly. It doesn't correlate super well. Like, fewer branches, obviously you're moving pretty fast in most cases with fewer branches, but when you look at this overall, I think what it tells you is that the number of branches probably doesn't have a huge impact. There's no one that has hundreds of branches that's moving very slowly, which I guess is good because you would be running workflows on hundreds of branches all the time. So, and then you look at team size, right? And the classic thing is you want a 2-pizza team, and I have so many questions about the pizzas because I am my own 2-pizza team in the right mood. So, but you look at what's the team size. Okay, with one you stretch the gamut. One person being a team, that's not a team. Let's just throw that data set, that data point away. But what we're looking at is actual measurement of contribution. So they have commits in the code base, and that's how we're measuring a team. So your team might have 8 people. If only 6 of them commit, it shows up as a 6-person team here. But what you'll see is that team size, there is quite a bit of variance in most of the cases, but it does start to stabilize around this 8 to 12 area quite a bit, where the variance of performance is way higher. So your net value score is higher. The green bar here in the center is the median. The top and the bottom is the quartiles of like where most of the distribution is, and then the full range of the line is the full range of what the data set looks like. So at 1, you get the full data set, no surprise. It starts to be a lot more predictable in this 8, 9, 10 range. Out here in 21, I imagine that sample size isn't that big because it's a really tight bar. But what it basically tells you is that team size maybe has some correlation to how fast you can move. I don't think it has a very strong correlation as to how many pizzas you can eat. And the other thing is that every organization has projects that they care less about than others. And this is kind of back to that cherry picking thing where when you're talking about primary application or service versus the other applications or the other things you're building in GitHub or on Bitbucket or whatever. First off, we don't ever count things that are in your org that don't run any CI. Like, so if you're not plugging them into Circle CI, they are just, we don't know about them. We know the projects exist. We don't know about them beyond that. But most orgs, they have these things that just sit there around -1, which basically means they sit there red forever or close to forever. And again, that's not that surprising when I think about it. There was a developer who wanted to do a spike on something. They learned how something worked. They put it in CI when they were working on it for a while. The last commit they put failed. They learned what they needed to learn, and that was the end of the world for them. So, great. That's not uncommon. These numbers here are actually the NVS, because we wanted to anonymize which companies these were, because I didn't want to name and shame companies. But you can see that even the ones that are really highly productive for most of the time still have things that sit here around this -1 mark, because there are projects they don't care about. But you can also see that there are some companies that are doing way better with way more stuff up here in the higher end. Maybe because CI has been put through their culture a little more, continuous delivery. They have a high trust culture where they can move quickly. There's a lot of things that you could posit as to why those happen. I'm less good at why with this giant data set. I can tell you what very clearly. So then you get into, what do anomalies indicate? Like, what about that one? Well, we know what customer that one is. So we went and asked them. Said, hey, you seem like a pretty good customer. You're moving at a pretty good clip. You have a lot of builds. That's a decent speed. Why is your failure rate so high? Like, why are you failing all the time? And they said, oh, yeah. We have this tool that was on an evaluation that we use in our CI system. And the evaluation ran out. And so it just fails that job every time. But we just move forward with it because we look and we see that, oh yeah, that failed, but it was that tool that failed because we ran out of the evaluation license. And so we just go do that. And so you think about that for a little bit. Like, the reason that you want feedback so quickly is so that you don't have to dig in and read the output to be like, is this still okay? They're basically just saying that, yeah, we just sit there with false negatives and we live with them and it's fine. That's a weird behavior. Also, if the trial thing is like $100 to go get the license, just buy the license. But so you go ask these companies why they do these things, and they're just like, yeah, we got used to it. So they can't use the postbacks to GitHub or Bitbucket that show you if something passed because they have to go dig into the output every single time. And they're like, yep, that's the expected failure. We're fine. Actually, it's green. Have anybody ever had a pipeline like that? Where like expected failures were still okay? I happen to have worked a few places where that was true. So I recommend not doing that. And then you get into NVS by language. So what if your NVS was the net value score? Remember the time red versus time green and all this. And this was interesting to me. PHP still pretty high up here. A little scary. We're a Clojure shop, which is funny. We did not stack this for Clojure. Puppet's also a Clojure shop, so I've worked at both Clojure shops that do infrastructure at this point. But Clojure seems to do pretty well. I think the things that are interesting is the groupings. When you look at dynamic languages grouped pretty closely together, stuff that's like kind of hardcore mobile app development is a much lower because it's a lot harder. That's hard with strongly typed things. You're trying to figure out how you do testing on mobile and development for Mac specifically, which is usually a tighter skill set. Fewer people know how to do it. Things might sit there read a little longer. So you should all write PHP. So in conclusion, when I want to wrap this up, I looked at all these data. What did we really learn? Well, surveys are great and data is great. I like having both sides of this because, again, a giant 31 million point data point set tells you what's going on. It doesn't tell you why. And I think you can get into why a lot more from asking questions. And that's what the survey is designed to do. Like there's hypotheses for each question and what they want to answer and why you answer it. Everybody's not doing better than you are. You come to a conference and you hear everybody talk about all the dogs, ponies, rainbows, unicorns, like all the great things that every company is doing. And you just think, man, I want to work there. They're so great. They are lying. And I mean this about every company. Like I have friends who work at Netflix and there's things there that are totally not okay, just like everywhere else. So don't get too caught up in that and think that you're not there and somebody else is this at the pinnacle of being the best at computers. No one's the best at computers. Few organizations look like what we see or hear in conference talks and do case studies about. And I think that's important to think about. Few organizations really are their personas they're putting on stage when we look at the data sets. If you're using CI, and I should actually say, I know for sure if you're using Circle CI, other CI tools, your mileage may vary. You're likely a high end, a medium, or a high performer. So I think that makes some investment in your flow through your system. Have your delivery flow, have investment in it. Work on those processes, work on those tooling, work on the culture of fixing things when they're red, not allowing that. And the data does show that basically fewer branches, master trunk development moves a little bit faster. More branches can slow you down. So it doesn't mean you don't do feature branches ever, but I think it's, you don't want to necessarily have a ton of long-lived branches, which is, again, not a surprise. You've always read that in the continuous delivery books or pamphlets or whatever. The data proves that out. So in final summary, survey is good, data is good, everybody's not better than you, organizations are lying, you should use Circle CI, master trunk development's okay, and you should probably be writing PHP. So that's what I have. I'm Mike Stahnke. I run the platform team at Circle CI. I'm happy to talk more about this stuff, but I know I'm also standing in the way of you and lunch, so I don't want to take up any more of your time. If you would like a beautiful hard copy of the 2019 State of DevOps Report, you can come get it from me. Again, the things that are ranty and sidebars, I probably wrote. The things that are really good and dive into data, Alana probably wrote. So that's my talk. Thank you. Enjoy the rest of your time here.